Okay, so this is going to be the college algebra final exam review for fall 2020. I started writing a like formula sheet, but then I realized y'all may want to write that down too. So I've only got this one down right now, and then I'll write them as we go, as we need them. There's 6 sections, 25 problems. There's 4 questions each from each section, I believe. Make sure, yeah. And then there's an extra one from one of them. I'm not sure which one I did. We're gonna need that paper that this is setting on. Try and get everything situated. I don't know what that is. Oh, here we go. So this first problem, for the given functions f and g, find the requested composite function value. So we're finding g of 3. So honestly, on this one, we don't need the f function at all because we're doing g of g. So 1, it's going to bother me. First, we're going to do 1 g of 3. So we'd have 2 times 3 squared plus 5. So 2 times 9 plus 5, 18 plus 5, 18, 19, 20. And we're going to need a calculator. So this is our first one. So then this one would be g of 3. And we're going to substitute this in for x now. So we'd have 2 times 23 squared plus 5. And that's for the calculator, because 23 squared is 529. But honestly, right here, I know that it's not this one, or this one, so our answer should be D. So 2 times 529 equals 1,058 plus 5 is 1,063. Let's see if on y'all's form that I copied, yeah, the answer key is on the back. So you should be good to go with that. Okay, first one's done. Let's see. Number 2, we have f of g of 1. So we're going to do number 2. That means we're going to start with g. You start with the last one. So we have g of 1, which would be 3 times 1, which gives us 3. And we're going to plug that into x on the f function. So we'd have the square root of 3 plus 4 should be the square root of 7. I don't know if y'all can see these on there, but I'm going to move it in case it's covering anything you might want. Just put boxes around these. Okay, for the given function, find f and g. For the given functions f and g, find the requested composite function. So we have f of g of x. Okay. So this one, since they don't give us a number, we're going to plug the g function in for x in the f function. So f of x equals 4x plus 13. G of x equals 2x subtract 1. This is all going to be x in this function. So we'll have 4 times 2x subtract 1 plus 13. So 8x subtract 4 plus 13, 8x plus 9, 10, 11, 12, 13. 3 is 8x plus 9. I'll be checking my answers as we do this. Yep. Oh, Determine the horizontal line test. Use the horizontal line test to determine whether the function is one-to-one. So before, when we were determining if it was a function, we just did vertical line test because you can't have a repeated domain when you're finding out if it's a function. Now, if it's one-to-one, that means you can't have a repeated x value or a repeated y value. So we do our horizontal line test, and if we only cross our graph once, like we're doing, this would be a one-to-one function. Solve the equation. So this is where I started writing down my formulas. And of course I folded it, so now it's going to be impossible to scan. So we have log 4 x plus 4 equals 3. So using this formula right here, we're going to change it to exponential. So I'd have 4 to the third power equals x plus 4. 4 to the third power is 64. Subtract my 4. 60 equals x. Double check. Yep. Okay, 6. We have 3 times 5 to the 2t, subtract 1, equals 75. We had one similar to this in our homework. If you remember, it was at the, I don't think it was our last section. It might have been. But since this is being multiplied right here, we have to divide first. So to 5 2t subtract 1 equals 25. And then there's different ways we could do this. We could change it to logarithm, or we can use the bases. So we could say that AU equals AV, or this is a rule. If our bases are the same, then U equals V. And I know 5 squared is 25, so I'm going to make my bases the same on this one. And then I'd have 2t subtract 1 equals 2. I would add my 1. So 2t equals 3. I'd divide by my 2. So t equals 3/2. Yep. But 7. This one's not bad at all. I'll write it on here so they're together. So we have 3 to the x power equals 81. 3 to the 4th power is 81 because 3 times 3 is 9, times 3 is 27, times 3 is 81. So 3 to x equals 3 to the 4th. And then that exact same rule right here, we'd have x equals 4. Or you could change it to a logarithm and do your base change and work it out that way. Okay, use the properties of logarithms. So this one right here, I'm going to write them both. So if we have e to the natural log, it would be 1. Or if we have the natural log of e, it would also be 1. Because they're kind of like inverses. So this is comparable to the square root of x squared. Or, oh, that's really it. Yeah. So they cancel each other out essentially. So if we had the square root of the square, they'll mark each other out. So on this one, this e to the natural log of 12 is just 12. First page is done. I guess since I did scan these on double set. And then right there's the opposite of it. So we had e to the natural log. Now we have natural log of e. So this would be 3. Okay, change the logarithmic expression to an equivalent expression involving an exponent. So we're using this top one right here. So a is 2, and it'd be 2 cubed equals 8. Remember, when you're doing these, they will make sense. They will work out. 2 cubed equals 8. 2 to the 8 does not equal 3. 8 cubed does not equal 2. 3 squared is 9. This is handy when you're taking the paper test. Also, if you're not taking the paper test, you may just want to go ahead and review the old review, not this one. If you're taking the test online, the other review is going to be more like that MyMathLab test than this one. Okay. Find the functions f and g so that f of g equals h. So f of g, this one would be 1 over x squared subtract 3. This one, would be 1 over x squared. This would be 1x. And then this one would be 1 over x squared subtract 9. Yep. All right. This one right here, we'd have 5 subtract 2x squared cubed. So no. This one would be, and we're still doing f of g, so we'd have 5 subtract 2 x squared cubed. No. This would be 5 subtract 2x cubed squared. That's it. And then this one would have been 5 subtract 2 x squared cubed. Yep. Good things. I feel like I'm speaking a foreign language. ADAB. All right. Find the exact value of the logarithmic expression. So this is going to be where we use our base change. So log, I'll do A and B because I always said big and little. I guess I could have did an L. Do the natural log of big divided by the natural log of the small one. So right here we'd have our natural log of 1 over 729. If you know your exponents really well, you don't have to do it this way. It's not a requirement to do it the way I do any of these, the exact way I do it. And I just want you to show your work regardless of how you do it. If you use a calculator, maybe write down that you use it, just so I have something to go off of when I'm going to give you your points, because I don't want to just say, oh, they got it wrong. I want to be able to give you some points, something. Okay, right here, there's that rule again. So it would be 5. Find the inverse of the function and state its domain and range. So you're just changing the domain and range. So on the inverse, domain and range switch. So we have -3, 4. So now I need 4, -3. Done. -1, 5. 5, -1. 0, 2. 2, 0, 6. 2, 2, 6. Yeah. That was easy. Indicate whether the function is 1 to 1. So no repeated x's, no repeated y's. So 9, 13, -15. 7, -4, 14. nothing repeated. BDCA. 13 BDCA. First page done. Keep my formulas nearby. The graph of an exponential function is given. Match the graph to one of the following functions. Okay, so right here, this is going to be like what you need to pay attention to. If it crosses through 0, 1, it's not being multiplied by anything. It's not being moved up or down. If it crosses through 0, 1, you just have the basic. And they all should cross through 0, 1. No shifts or stretches. That should help. Okay, right here, we're going through 0, -1, which means it just got reflected across the y-axis. If it got reflected across the y-axis, the negative is, why did I say y-axis? X-axis is in the front. If the negative is with x, it's across the y-axis. So this one is here. It's across the y-axis. There, since I said it wrong so many times, there it is. Okay, use the change of base formula, which is this. So we have our natural log of 25 over the natural log of 3, and we're going to round. You have to use a calculator on this one. I will have mine if you're taking it here. Big over small. 2.929, but we're rounding, so 2.93. The graph of a logarithmic function is shown. Select the function which matches the graph. So remember, exponential and logarithmic are shifted. So since this one doesn't cross at 1, 0, it has been shifted. I'm gonna write that here. And since it didn't cross at 1, 0, I know it has been shifted down. So this one right here is a +2, so this would be left. This one would be up. This is down. This would be right. That paper, remember, you can have as many notes as you want on this test. Change the exponential function to an equivalent expression involving a logarithm. So we're using this again, but now we're going to have log 6 to 216 equals 3. Didn't even check that once. But also on these, they are going to be the answer. So if you can't remember or you get really confused, you can do your base change. 6 to figure out which one actually equals what it says it equals. I think it should be the only one. Let's see. That's not a reason, that just screws that. Yeah, no. It should. You're good on that one. Okay. The graph of a one-to-one function is given. Draw the graph of the inverse as a dashed line or curve. So these are both the same. You're looking for your inverse, so you're looking at that dashed line. So if you have eye problems, wear your contacts. But remember, for the inverse, it's going to be, I can't draw a straight line. that y equals x line from corner to corner, and it's going to line up going through it. So if we had it over here, this one's not going to mirror it. I guess that's the word I'm looking for. Express as a single logarithm, and it's plus sign, so that means this one is the rule. And it would be m times n, and if we separated it out, it would be log the same base plus and then the opposite of that one. If it was being divided, it would be top subtract bottom. Okay, so here we're going, it says single logarithm too. This is not a single logarithm. Get rid of that one. Oh, look at that. I'm going to say B is corrector. I'd probably give you points for that one. Let's see what they gave us. 21 is B, 22 is B, and 23 is C. Since it literally says in the property to put the parentheses, this one is going to be both of them. I'm going to make a note. But, okay. So be it. So there's a 50-50 chance on number 23. Determine whether the given function is exponential or not. If it is exponential, identify the value of a of the base a. So we're just looking for a. Oh, that's easy. It's 5. Oh, look at this. It's not, is it? So at 0, we have 1. So it's not being multiplied by anything. At 1, it's 5/7. So since at 0, it's 1, anything raised to the 0 power is 1. Anything to 1 is itself. Anything to the negative power would put it under. So if we wanted to check this, if we had, if it is 5/7, that would mean 5/7 to the -1 would give us 1 over 5 to the 7th, which we would do keep, change, flip to simplify this because this is obviously not it. We'd have 1 times 7 over 5, which would give us that 7/5 that we got right here. So our answer is, in fact, 5/7. Right. Right. Write as the sum and or difference of logarithms. Express powers as factors. So one more rule. And that is, I don't remember the exact variables we used before, so we're going to wing it. It's something we hadn't used yet. So let's do a, we've used X, we've used Y, we've used M. Let's do a V, because we used a V as an exponent up here. They don't want you to do it like this, so we'd put that V in the front. And I know I used different ones on the paper because I can't remember what I did, but it's the same rule. I just changed the variables and they don't actually stand for things, so I think it's okay. Maybe not. We'll see. Okay, but this one's going to combine this rule and this rule. So first let's write it log for x to the 5th top subtract bottom. Then we're going to do our express powers as factors. So we'd have 5 logarithm of 4 to the x subtract 7 logarithm of 4. Fine. Okay, wait. I did the plus sign now. This is very, very important. And if you would have wrote it out, and I saw that, and that you made that little tiny mistake, but you worked it out right, and I have done it already, I'd give you full points. I'm looking for whiteout. So when I scan these, nobody gets like super confused. But if I was perfect, it wouldn't be fun. Okay. So if anyone has any questions, pay attention to little tiny signs when you're taking your test. We're going to review this in class as well. Yep. That's all I got.